So this lesson is on the remaining properties of exponents, and we're going to today focus on using the zero property and also the negative exponent property. So the first one, talking about what happens when you have an exponent of a zero, well, any number to the zero power is simply just one. So other than the number of zero, of course, but anything else, if you raise it to the zero power, the answer would just be one. So it doesn't matter if it's a variable, if it's a number, a very large number, a negative number, a very small number, or even a whole big product of something, but as long as it's in parentheses raised to zero, it would still equal one. Then the second property has to do with negative exponents, and basically if you have anything, any term, any variable, number, combination of those raised to a negative exponent, in order to get the negative exponent to become positive, you would just take that specific term and move it to the opposite side of the fraction. Now, just to show you an example, if you have, let's say, 2 to the negative 4 power, right, you would move that to the bottom, and it would now become 2 to the positive 4 power. But if you had something like a negative 2, for example, to the negative 4 power, you would move that to the bottom as well, but only the exponent would change to a positive 4. The actual number itself, since it was a negative number, that does not change, just the exponent changes. So I just wanted to make that important point there. So let's take a look at these examples here. So if we take a look at this first one, now anytime something is not already in a fraction form, for me, I like to just put it over 1 so I can kind of keep it separated into like both a top and a bottom, or numerator and a denominator. So this 4 is being raised to a negative exponent. So in order for me to make that 3 a positive, I simply have to just put the 4 on the bottom, and then 3 becomes positive. Now, because this is a number and not a variable, I could work that out, and 4 to the third power is 64. So it'd be 1 over 64. Now to take a look at the next example, this is simply just 1 because any number raised to the 0 power is just 1. Okay, now C, you're going to have two options. Option 1, since this number here is already a fraction and it's raised to a negative exponent, I can simply just flip the fraction and change the 3 to a positive. So basically my 3 from the 3/2 went to the bottom, my 2 went to the top, my exponent became positive. But then, of course, this problem would have to be finished by bringing that exponent to both the numerator and the denominator. So I would have 2 to the third power over 3 to the third power, which simplifies to 8 over 27. Now, another way you could have done that problem would be to get rid of the parentheses first. So if you had done it that way, you would have brought the negative 3 to your top number, so it'd be 3 to the negative third. Then you would bring the negative 3 to the bottom number, so 2 to the negative 3. And then you would say, oh wait, each of these have negatives, so I need to move the 3 to the bottom, make the exponent positive, move the 2 to the top, make that exponent positive, and now I could simplify it to 8 over 27. So we had to get rid of the parentheses and the negative exponent, but it didn't matter which one we did first and which one we did second. All right, so a couple more practice problems. All right, so this one, it's raised to 0, so there's nothing to be done there. It just equals 1. Number 2 has a negative exponent, so since currently this negative 5 would be, like we say, on the top of a fraction, we're going to move it to the bottom of the fraction. Now notice my 5 is staying negative, but that exponent, that negative 4, is what's going to become positive. So the exponent changes sign, but not the actual base. Number 3, our number is on the bottom, this power down here. So the 6 is going to move up to the top, and then my exponent 2 becomes positive, which is just over 1. Now this one could be simplified, so 6 squared is 36. And the last one actually could have been simplified as well, because negative 5 to the 4th power is actually positive 625. And then finally, number 4, that's one of those ones where there's 2 different ways we could go about doing it. So the first option would be I could simply just flip the entire fraction, since the entire fraction has the negative exponent, and now my fraction has a positive exponent. Then I would have to bring that exponent to each of those numbers, and then I would work it out, and this would be 8 over 125. Now the other option for this problem would have been to kind of distribute that exponent. So it would be 5 to the negative 3 over 2 to the negative 3. Then we would flip the 2 to the top, the 5 to the bottom, so we could make the exponents positive, and then it would still work out to 8 over 125. Okay, so let's continue on. So here's an example of where we have a negative exponent inside, or in a problem where we're also multiplying. So we're multiplying these 2 powers. They both have the same base of 13. So typically when we find the product of 2 powers, we add the exponents. So one option for this problem, okay, would be to just simply add those exponents. So 16 plus negative 14. And that would, of course, just equal 13 to the second power, which then, of course, works out to be 169. Now, the other option for this, so that would be totally fine if you did it that way. But the other thing is sometimes we just like to get rid of the negative exponent first before we do anything. So I could have left my 13 to the 16th power on the top. I could have moved the 13 to the negative 14th power to the bottom, which would have made that 14 a positive, and then I could subtract the exponents using my quotient property. So if I did it this way, then it's 13 or 16 minus 14, which would just be a 2, and again it's still 169. So you're going to get the same answer either way. All right, now example B, these 2 exponents here would need to get multiplied. So I still have a negative 2. That has not changed. Remember, whatever's in the parentheses isn't going to change. Negative 4 times 2 gives me a negative 8. Now I can't leave that negative exponent, so I would have to move the entire negative 2 to the other side, making that 8 positive. And now I could work that out on my calculator. I believe it is 128. And because it's a negative 2 to a even number power, the negative will end up canceling out, and you have positive 128 on the bottom. Okay. So taking a look at number 5. Okay, so there's a couple ways we could look at this one. One, if we think of our quotient property that we have done the other day, we would subtract our exponents. But if you're subtracting negative 5 minus negative 5, remember when you subtract a negative, you're really adding. And so that's going to become 8 to the 0 power, which of course equals 1. The other option would be you could just say, oh, this one has a negative exponent. I need to put it on the bottom and make the exponent positive. This one has a negative exponent. I'm going to move it to the other side, make it positive, and then 5 minus 5 is 0, and you obviously go from there. Or you could just say, oh, wait, those cancel, and it equals 1. It doesn't matter. There's multiple ways to get the answer in some cases. Okay, number 6, the 9 has a negative exponent, so we're going to move it to the top, making the exponent positive, and then 9 squared simply works out to 81. Okay, number 7, the base numbers are the same, so we can add the exponents, giving us negative 4 to the negative 2. Unfortunately, we are not allowed to leave negative exponents for our final answer. So this negative 4 would need to go down to the bottom, making my exponent a positive 2. And then, of course, negative 4 times negative 4 would be a positive 16. So my answer is 1 over 16. If you had done it a different way and got the same answer, that's fine. And then finally, number 8, one option would be to bring the 10 to the negative 3 to the top, making the 3 positive. I like this option because now I can just add 2 positive numbers, which makes this a little bit easier. It's 10 to the 5th. The other option for this one would have been to just do subtraction here, but subtracting with a negative can get a little dicey. So you have to remember when you subtract the negative, you're really adding, and that's how we would get it there. And of course, you could put that in your calculator and get the actual number as well. Okay, so now we're going to use all of the properties we've learned together to simplify some of these larger expressions. So there's no correct order per se in which to do them, but I like to follow a certain order just to help keep myself organized and make sure I don't miss anything. So I find it easiest to get rid of my parentheses first. And then the second thing I do is get rid of any negative exponents. And then I kind of follow doing my either multiplication or division and stuff like that from there. So to get rid of my parentheses, if any exponent on the outside of the parentheses needs to get applied to each and every part of that product. So the 3 is going to get that exponent of 3. This m to the negative 2 is also going to get it. But remember, when there's already an exponent there and you're distributing another exponent to that, you need to multiply those. So negative 2 times 3 would be negative 6. And then the n is also going to get the exponent of 3. So now the next thing I like to do is get rid of any negative exponents. And the way I do that is simply by moving that term to the opposite side of the fraction. So 3 to the third power is going to stay on the top because it's not a negative exponent. However, this m has a negative exponent. So if I move my m to the bottom, then the 6 becomes positive. The n is going to stay where it is because it already has a positive exponent. So now the only other thing I've left to do is work out 3 to the third power, which is 3 times 3 times 3, and that's 27. So I have 27 n to the third over m to the third for that final answer. Okay, so let's look at the next example. I'm gonna work on just this little portion here in the parentheses first, because that's just the way I like to do it. So this little 2 is going to go to the negative 5. Now notice my 5 is a negative, so it stays in the parentheses. It's also going to go to this s, and it's also going to go to the t. Now these are all being multiplied together in here. So then I'm just going to continue writing my other thing on the top, which is t to the negative 4. On the bottom, I have a negative 10, an s to the third, and a t to the negative 8. Okay, so the next thing I like to do, as I said, is get rid of negative exponents. So negative 5 is not an exponent. Negative 10 is not an exponent. So I'm going to leave those for a minute. But this t and this t have negative exponents. So I'm going to rewrite the things that have the positive exponents exactly where they are. But now this t is going to go to the top. So it'll be t to the 8th. And then on the bottom, I'm going to take this t to the negative 4 and put it down the bottom, so it'll become a positive 4. All right, so once I've gotten rid of my parentheses and my negative exponents, I want to solve any exponents I can or do any multiplication or division. So this piece here, negative 5 squared, is actually going to be positive 25. And then I have the negative 10 on the bottom. I also have these two t's here on the top, and if you remember, when you're multiplying two powers that have the same base, you add the exponents. So that's going to give me a t to the 10th on the top. So after I multiply, now I'm going to divide. 25 divided by negative 10, you just divide normally. Now 10 doesn't go into 25 evenly, so we're just going to leave it as a fraction in lowest terms, which would be negative 3 over 2. Now with the s's here, remember our quotient property, we subtract the exponents and we put the answer wherever the larger one was. So 3 minus 2 is 1, and it's going to have to go on the bottom. And then when we do the t's, 10 minus 4 is going to leave us with 6, and that is going to go on the top. So our answer is negative 3 halves t to the 6 over s. You could do the negative on the top or the bottom. That doesn't matter as long as you've simplified everything accordingly. Okay. All right, so we got a couple more of these. Okay, the first one, I have the parentheses here that I'm going to get rid of first by bringing this 4 to each and every term inside, or each and every part of this product, because this term is actually one large term. So we have 5 to the 4th times x to the 2 times 4 is going to give me 8. Then times y to the negative 3 times 4 will be negative 12. And then z to the 4th. Now, I don't like the fact that there's a negative on this y here. So I'm going to move that to the bottom, making that 12 positive. My x to the 8th and my z to the 4th are going to stay exactly where they are. And the 5 to the 4th, I can work that out, and I believe it's 625. So that would be my simplified answer. All right, number 10 does not have any parentheses, but there are 2 negative exponents here. So for me, I just like to recopy it, and I move my negative exponents to the opposite side. So my 4 stays, my n and p cubed stay. On the bottom, my 12m squared stays and the p stays. So these two are just going to swap places. So the n to the 15 is going to go on the top, but now I can make that 15 a positive, and that m squared is going to go to the bottom and, of course, become positive. Once I do that, I can now combine my like variables. So I have n to the 15, and that's really an n to the first, right? So that's going to give me n to the 16th. And then on the bottom, we have these two m's here. So that would give me m to the 4th. And now I want to do any dividing I can do. So the 4 over 12 simplifies to a 1 and a 3. N to the 16th and the m to the 4th. There's nothing else I could do there. But here I have p to the 3rd on the top and a p on the bottom. So that's 3 minus 1, which gives me 2 left on the top. And that's basically my answer. I don't really need the 1 from the 1/3 there, since there's other stuff on the top there. So it's n to the 16th p squared over 3m to the 4th for my final answer. Okay, and then the last one, I'm going to start out by getting rid of my parenthesis first. So this is going to become 2 to the negative 3, r to the 2 times negative 3, which is negative 6, and then t to the negative 3, and then I still have this r, s, and t to the 4th on the top. On the bottom, I have a 6, an r to the 6th, and an s to the negative 3. Okay, now notice I have a few negative things here. All the negatives I just highlighted, I'm going to rewrite this, moving them to the opposite side. So now on the top, I still have this RST to the 4th here. RST to the 4th, but then this S is going to move to the top and become a positive. On the bottom, I have my 6, my R to the 6th, and now I'm going to move these 3 all down. So I'll have 2 to the 3rd, R to the 6th, and T to the 3rd. So it seems like there's a lot of steps, but that's just so I don't miss anything. It just helps keep it organized. right, so at this point, we want to multiply anything that we can. So I see that on the top, I have an s and an s cubed. So that means I have an r, and then this is really going to be s to the fourth, and then t to the fourth, right? Now on the bottom, I have 2 to the third and a 6, and I want to multiply those. Well, 2 to the third is actually an 8, and 8 times 6 is 48. Then I have r to the 6th and r to the 6th. So when I multiply those, I'm going to add those exponents and get r to the 12th. And then I have t to the third. And then the last thing I need to do is simplify my r's. So that's going to be subtraction now because I'm dividing. So when you're dividing, you subtract the exponents. Remember, that's really a 1 there. So 12 minus 1 is r to the 11th. And then the t's, 4 minus 3, which is a 1, and that's going to go on the top. And that's it. So hopefully that helps you see how you're going to use all the different properties of exponents to simplify an algebraic expression.